Hi students, today we're going to be going over graphing square root functions. Sorry I couldn't be with you guys today. I have training at school today. Um, but anyways, unit 4, we know that we're learning about square root functions, right? So our parent function is f of x is equal to the square root of x, right? That's our parent function. If we think about our x and our y's, right? So hopefully you guys will see how I'm choosing these. Square root functions, I know usually, let me just think about this. We usually pick like -2, -1, 0, 1, and 2. Square root functions, well, in this lesson, we're going to be working with real numbers, right? So technically, we couldn't have any negative numbers, right? If we had a negative number underneath the square root, that would be imaginary numbers. So once again, we're only working with real numbers this lesson or this for this unit. But thinking about this, right? So we have to have the square root, and then whenever I take square roots of these, they have to be whole numbers. So this is why I'm going to strategically choose my x's. I know that the square root of 0 is going to be 0. Next, what would be the next higher up number that would give me a whole number? Well, the square root of 1, right? The square root of 1 would give me, well, just 1. But next, let's see, the square root of 2, that wouldn't give me a whole number, right? If you put that into your calculator, it'll give you a decimal. But the square root of 3 also would not give us a whole number. The square root of 4, though, so the square root of 4 would give us a whole number, and that would just be 2. So for this unit, we're just using 0, 1, and 4. And then once again, you don't have to memorize these values. You just take the square root, right? The square root of x is just all of these numbers. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And as before, we go ahead and graph this function. So let's see, 0 comma 0 would be about right here. 1 comma 1 would be right there. And then 4 comma 2 would be right here. And if you don't know what a square root function looks like, this is it looks sort of like it. So this is sort of what it looks like. And yeah, so that's what our square root function looks like, right? It continues off. We call this a plateau. It's going to look like it's flattening, but technically it never stops increasing upwards. All right, so as usual, we go over domain and range. So domain, the furthest left our graph goes, well, it doesn't go any further left than 0, right? So remember with a bracket. And the furthest right it goes, well, it does not stop going to the right. So it goes all the way to infinity. The range, let's see, the range, the lowest this graph goes, right? That would be 0. We can't go any lower than 0. And the highest this graph goes, well, as I said before, this graph, even though it looks like it starts to, I guess, plateau off or start to get flatter, it doesn't stop increasing, right? It doesn't stop increasing. So yeah, it goes all the way to infinity. Our endpoint, this is similar to what we did with our quadratics. This is similar to the vertex, right? So it's obviously not called the vertex, but this we could call this an endpoint. An endpoint, well, yeah, intuitively this would be that. So endpoint starts at 0 comma 0. All right, increasing or decreasing. Well, yeah, this is going to be an increasing function, right? Increasing from left to right, it is increasing. And then let's see at what interval. Well, it's increasing on the interval from 0 all the way to infinity, right? Increasing from 0 to infinity. All right. So if you guys remember these types of lessons, it's H, and K, right? So now let's go ahead and try to figure out, let's try to write out that function, right? F of x is equal to A multiplied by the square root of x minus h plus k. All right, so very, very similar to what we had before, but now the only difference is that instead of like a square root or a function, or sorry, this is a square root, instead of a square, or instead of an absolute function, we have a square root in there, right? And hopefully you guys can see similarly, if this, just like how with absolute values, if it was inside the absolute value, that was our h function, or sorry, our h value. But now our h value is whatever's underneath the radical. If it's outside the radical, just like if it was outside of a parentheses, it's our k value. And of course, any number in front is our a value. All right, so starting off with question number one, just a reminder of our transformations. I always like to start us off with transformations first. So let's go ahead and try to do that. Well, our a value is negative, so just a reminder if you guys forgot what that does, it reflects it down, right? So reflect down. And then let's see, we don't have any plus or minus underneath the radical, right? This -3 is outside. It's not underneath the radical, so that's our k value, right? Our k values moves it up or down. Since this is a negative, it moves it down 3. All right, and very, very similar to what we did before, right? We always start off with our parent function. And now, instead of like -2, -1, 0, 1, and 2, we're going to use these three numbers, 0, 1, and 4. So once again, those are the only three numbers you have to memorize. Why is you don't have to memorize? Because, well, we just take the square root of each of these. Square root of 0 is 0. Square root of 1 is 1. And square root of 4 is 2. And then now we apply the same transformations as we've been working with all semester, right? This negative, we're going to multiply that by my y, so -1y or negative y. And our k value is always vertically, right? It's a vertical transformation, so we subtract it from our vertical axis or our y-axis, right? And then our x just stays the same. Remember, x is only affected by our h value. We don't have any h here. So our x's, we just rewrite as is, 0, 1, and 4. And then our y's, we're going to multiply that by -1 and then -3, right? So let's see, that'll just be -3. Let's see, 1 multiplied by -1 is going to be -1. -1 minus 3 is just -4. And then next, we multiply this by -1, so that gives us -2. -2 minus 3, right? -2 minus 3 gives me -5. Yeah, now let's try to go ahead and graph these coordinate points. 0, comma, -3. 1, comma, -4. And then 4, let's see, 4, comma, -5. Let's 1, 2, 3, 4. 1, 2, 3, 4, 5. 4, comma, -5. Yeah, let's try to make that shape of what we tried or we started with up here, right? It looks similar. And yeah, now let's try to check our graph just by, using an eye test, right? Seeing if it reflects down. Yeah, it does reflect down, right? Usually it starts going up, but now it reflects downward. And then does it move down 3? Well, yeah, usually we start off at 0, 0, right? This start off at 0, 0, and then we move down 3. Nice. So we have our graph. It looks pretty good. All right. So domain for this left our graph goes is negative, or sorry, not negative. We start off at 0, and then we go all the way to positive infinity, right? The furthest right our graph goes does not stop growing to the right. Range. Let's see. The furthest down our graph goes is negative infinity, right? It does not stop going down. And it goes all the way up until the highest our graph goes is at -3. Endpoint, this point right here is going to be at 0, comma, -3. Increasing and decreasing. Well, this graph from left to right, we are going downward, right? So we are decreasing. We're decreasing from 0 all the way to, let's see, 0 to infinity. We're decreasing on that interval. All right, y-intercept. Well, this is where our graph crosses the y-axis. Yeah, it does have a y-intercept, right? If any, sometimes we won't. But yeah, that would be at 0, comma, -3. Zeros does not cross our y-axis, right? Our x-axis. Remember, zeros is wherever our graph would cross the x-axis, right? This is just another way of saying x-intercept. So yeah, we would say none. And yeah, that's our first example. All right, let's try to do number 2 together. We have 2 multiplied by x minus 4 minus 4, the square root of x minus 4 minus 4, right? So same thing, x and y, right? I mean, I shouldn't say same thing exactly, but we start off with 0, 1, and 4, right? Once again, I chose these because these are going to, and when we take the square root of this is going to give us nice whole numbers over here. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. Next, x and y, we apply our transformations. So now we have an h value, right? This -4, this -4 is underneath the radical. So remember, we always say it's the opposite though, right? I should have wrote this smaller, sorry. X plus 4, right? X plus 4, it's going to shift it to the right 4. Right, so let's go ahead and add 4 to each of these x values. 0 plus 4, that gives me 4. 1 plus 4, that gives me 5. And 4 plus 4, 4 plus 4, yeah, that gives me 8. Sorry, I didn't think I was doing that correctly, but and then next, right, our a value. This is going to be a vertical stretch. It stretches our graph by 2. So that's going to be our vertical axis, which is, we're going to multiply that by y, which is our vertical axis. And then once again, we're going to subtract 4 from it because it moves it down 4. It affects it vertically. Right, so now let's see. 0 multiplied by 2 is just 0. Minus 4, that's going to be -4. Let's see. 1 times 2 is 2. We subtract 4, so that gives us -2. And then lastly, 2 times 2 is 0. No, sorry. 2 times 2 is 4. 4 minus 4. That's what I meant by 0. Yeah, that would give us 0. And then before we go ahead and graph this, let's just try to verify it using our transformation so that we can see maybe if we're doing it correctly. Ideally, it should match up with our transformations. So let's see, transformations. We know this 2 is going to be, that's our a value, right? It's going to vertically stretch. Sorry, we usually just say stretch. Yeah, stretch by 2. This x minus 4, as I said before, that's going to move it right 4. That's why we did plus 4 up there. So right 4. And then lastly, minus 4, right? That's our k value. So it's going to move it downward 4. Down 4. All right, so ideally our points should look like these transformations. So let's see. 1, 2, 3, 4, comma, -4. 1, 2, 3, 4. 5, comma, -2. And then let's see. 8, comma, 0. And let's try to go ahead and... So let's look at our transformation. Stretch by 2. Yeah, that's right. I can't tell exactly if it's stretched by 2, but it does look like it's stretched by 2, right? Looks a little bit more, looks like it increases a little bit faster than our original parent function. Right 4. Yeah, we usually start at 0, comma 0. We definitely went right 4. And then we also definitely went down 4, right? Right 4, down 4. That's where our endpoint is. So yeah, I mean, it looks pretty good so far. All right, so my domain, remember the furthest left my graph goes. So the furthest left my graph goes would be 4. Once again, with a bracket. Furthest right my graph goes does not stop going to the right, so infinity. My range, what's the furthest down my graph goes? Well, it doesn't go any lower than -4. Yeah, -4. But it does not stop going up, right? Doesn't stop increasing, so we say infinity. Highest my graph goes doesn't stop increasing. My endpoint, that's going to be at 4, comma, -4. Increasing or decreasing? Yeah, from left to right. Left to right, we are increasing. And where are we increasing at? Let's see. We're increasing from 4 all the way to infinity. From 4 all the way to infinity. All right, y-intercept. We don't have any, right? Does not cross the y-axis. Are zeros, if any? Yeah, it crosses the x-axis at 8. So 8. Yeah, and that's our problem number 2. All right, so at this point, ideally, you guys should go ahead and pause the video and try to do questions number 3 and 4 by your guys' selves. All right, so hopefully we should have done this by ourselves. Let's go ahead and try to maybe check our work with this. Once again, x and y's, it's going to be 0, 1, and 4. Those are my first 3 perfect squares. All right, then take the square root of those numbers. That would be 0. Square root of 0, 0. Square root of 1 is 1. Square root of 4 is 2. All right, our transformations. Let's try to write that out. This negative, right? This negative tells us we're going to reflect down. That 1/4, remember when it's less than 1, right? We say it's going to be a compression, or it's going to shrink it by 1/4. Or I think I used compress with you guys. Doesn't matter. Either shrek or, let's see, or compress. I'll just write it. Either word you use, I'll still give you credit for it. Compress or shrink by 1/4. And then let's see, what else do we have? We have this h value. Remember, this is going to be the opposite, so that tells us we go to the right one. And then lastly, this +4 tells us, well, since it's positive, it tells us we go up 4. All right, so remember this h value, it tells us we go right 4, so we're going to go x plus 1. And then we're going to add 1 to each of these x values. 0 plus 1, that'll give us 1. 1 plus 1, that gives me 2. 4 plus 1, that gives me 5. All right, x, we have, let's see, negative 1/4. So we're going to multiply our y by negative 1/4. Just so you guys can do it in your calculators, let's just put that as 0.25. Right, 1/4. That's the same thing as a quarter, right? A quarter, 25 cents. And then plus 4. All right, so let's try to do this math here. Sorry, I meant to write 0.25y, right? We want to multiply all of these y values by negative 0.25 and then add 4. So 0 multiplied by negative 0.25 is just 0, and then add 4 gives me 4. Let's see, 1 multiplied by negative 0.25 is just going to be negative 0.25. And then negative 0.25 plus 4, that gives me 3.75. And then let's see, 2 multiplied by negative 0.25, that's going to be negative 0.5. And negative 0.5 plus 4, that'll give me 3.5. Yeah, so this graph is going to be tiny. And yeah, that makes sense, right? We're shrinking our graph by 1/4. So yeah, that's going to be a little bit more smaller. But anyways, let's try to go ahead and graph this to hopefully see that we did it correctly. 1, 4. 1, 4. Nope, counted wrong. There we go. 1, 4. 2, 3.75. 2, 3.75. And then lastly, 5, 3.5. Let's see, 5 would be 1, 2, 3, 4, 5, 3.5. Maybe I should have graphed this point a little bit higher, but I mean, it's so close, right? It's a little bit tougher since this graph is a little bit smaller. But yeah, that would be our graph. Our graph is, I mean, I don't know exactly if it's shrunk by 4, by 1/4, Yeah, it definitely looks smaller. And let's try to see, does it reflect down? Yeah, usually it's increasing upwards. Now it's decreasing downwards. And then let's see, we're gonna go right one and up four. So yeah, we usually start at 0, 0. We went right one, up four. So yeah, it looks good to me. My domain is gonna be, let's see, negative, or sorry, not negative. We start off at one, right? The furthest left our graph goes is one, and then we go all the way to the right to infinity. My range, what's the lowest my graph goes? Well, once again, this does not stop going downward, right? So my range is going to be negative infinity. And the highest my graph goes, well, it stops at 4. Yeah, it stops there at 4. My endpoint is going to be 4 comma, nope, sorry, 1 comma 4. 1 comma 4. All right, increasing or decreasing? Well, yeah, this is going down, so it's going to be decreasing. At, let's see, decreasing. Well, it's decreasing on the interval of, well, 1 to infinity, right? On that interval from 1 to infinity. The y-intercept, y-intercept, I don't have any. Don't have any, none. Doesn't cross my y-axis, right? My zeros, though, I will have zeros here, and I'll show you guys how to get that later. We'll save that part for another lesson. Um, hmm. Basically, we haven't gotten to solving yet. So in order to solve this, remember we set our equation equal to 0. So we would have negative 1/4 square root of x minus 1 plus 4 is equal to 0. We would solve for zeros by, yeah, setting my y equal to 0 and then solving from here. But yeah, once we get into that, we can go ahead and do that. Yeah, let's not worry about it for now. All right, question number 4. All right, this one, I don't want to, I wasn't trying to trick you guys here, but I want you guys to understand that, well, the number in front, technically it's not always going to be our a value, right? It's the number in front where it's being multiplied. So there's nothing different about me rewriting this function as f of x is equal to negative 4 square root of x plus 5 plus 3. Right, so why did I rewrite it like that? Well, now when I rewrite it like this, hopefully you guys can see that our a value is negative 4 and our k value is plus 3. Right? So if it helps you guys, always try to rewrite it like that. But anyways, once again, same thing. X and y, 0, 1, and 4. The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. My x, my h value, sorry, I'm going to go to the left 5, right? Opposite, so I write x minus 5. Let's see, my a value is negative 4, so I'm going to multiply that by my y, negative 4. And then I'm going to add my k value to that, plus 3. So let's see, subtracting 5 from my x value is 0 minus 5, that's going to be negative 5. 1 minus 5, that's going to be negative 4. 4 minus 5, that's going to be negative 1. Taking care of my y values, let's see, 0 multiplied by negative 4 is going to be 0, plus 3, that's going to be 3. Let's see, 1 multiplied by negative 4 is going to be negative 4. Negative 4 plus 3, that's going to be negative 1. And then lastly, 2 multiplied by negative 4 is going to be negative 8. Negative 8 plus 3 is going to be negative 5. I think I did that correctly, but we can always check, right, using our transformations. Let's see, transformations. My a value is negative 4. So that negative tells me I'm going to reflect down. That 4 tells me I'm going to stretch by 4. Stretch by 4. My h value tells me that, as I said earlier, left 5. And then this 3 tells me I'm going to go up 3. Yeah, so let's try to go ahead and graph this. Hopefully we did this correctly. Let's see, negative 5, 1, 2, 3, 4, 5, comma 3. Negative 4, comma 1. Negative 4, comma negative 1, sorry. Negative 4, comma negative 1, my bad. Let's just ignore this coordinate point when we're connecting the dots. And then negative 1, comma negative 5. Negative 1, comma negative 5 would be right about there. And once again, this one was an error, so I'm going to go ahead and try to avoid that one. And yeah, that's my graph. So let's see. Did we reflect down? Yes, we did reflect down. We are going downwards. Did it stretch by 4? Um, yeah, I think it stretched by 4. If we look at this, we'll go a little bit more into why we think it stretched by 4. But anyways, it definitely looks like it increases, or sorry, decreases faster, right? It definitely looks like it stretched by 4. Left 5. We start over here. We went left 5. Yep. And then did we go up 3? Yes, up 3. So yeah, it looks pretty good so far. Domain. The furthest left my graph goes is going to be negative 5 to infinity, right? The furthest my graph goes to the right is infinity. The range, my graph does not stop going downward, right? The lowest my graph goes is negative infinity. The highest my graph goes would be, let's see, positive 3. Endpoint, that's going to be at negative 5, comma 3. Let's see, is this increasing or decreasing? Yeah, from left to right, we are going downwards. We are decreasing. And we are decreasing from, well, yeah, from negative 5 all the way to infinity, excuse me. And then my y-intercept. My y-intercept is where this graph crosses the y-axis. So it doesn't look, it's not going to be a whole number, right? So we have to sort of use what we learned last semester. Right, last semester we learned that we plug in 0 for x and then we solve, right? So 3 minus 4 square root of 0 minus 5, or I'm sorry, 0 plus 5. Yeah, so that gives us, let's see, 0 plus 5 is just going to be rad 5, and then we can't simplify that anymore, right? So I know this seems weird, but 3 minus 4 rad 5, that's its simplest form. Doesn't look simple, but yeah, we can't simplify this anymore. 3 minus 4 rad 5, that'd be our y-intercept. Our zeros. I know it looks like it crosses our 0 at exactly this point, but we have to be a little bit more precise, right? So once again, we'll go over how to solve these when we have our solving lesson. I think we'll go over that on Thursday. Anyways, if you guys didn't want to know how to solve this, I won't go over the exact, but I'll go over what we can do exactly like we did with this one, right? We set our equation equal to 0, set our equation equal to 0, and then we solve from there. But we don't have to worry about it for now. All right, the last part of our lesson, writing a square root functions from a graph. We want to go backwards, right? So using what we have learned, now let's go backwards. All right, so usually I like to write out my transformations from here and then put it into my equation. So let's see, my transformations, let's just try to zoom in into this. Question number 5, sorry. My transformations, so usually we start off at 0, comma 0. I go to the right 3, and I go up to, so I don't know where I can write this. Let's just write it over here. Right 3, up 2. And now here comes the part where maybe some students might get confused here. I don't think you will. But looking at our transformations, we usually have if it's reflected up or down. Well, clearly this is not reflected downward, right? This is clearly increasing, so it's not reflected down. But now we want to see whether or not it is transformed or vertically stretched, sorry, whether it's stretched or compressed. So if we think back to our parent function, I'm just going to flip to the other page. Oops. Here it is. When we first started off, right, this is a way to tell whether it's increased or vertically stretched, right? Usually we go across one and then up one, right? Across one and up one. But if we notice over here on question number 2, we went across one and then up two, right? Across one and then up two. So hopefully you guys can see how, well, if it's stretched by 2, instead of going across one, up one, it goes across one, up two. And then you guys can see where it's sort of the similar stuff happens with question number 4, right? So even though it reflects down, it should, if it wasn't stretched by 4 right here, it would go down, or sorry, across one and then down one. But instead of going across one and down one, it goes across one and down 4. So ideally that makes sense. Conceptually, we're multiplying it by 4. All right, so that's how we can tell whether or not it's vertically stretched. But anyways, going back to our actual problem, right? This isn't vertically stretched. We go across one and then only up one, right? So it doesn't have any vertical stretch, and those are only transformations, right? So applying that are transformations. Remember, right 3, that's going to be opposite of 3, right? So f of x is equal to, we don't have any a values, so let's write our square root of x. And then we're going to go to the right 3, so we're going to subtract 3. And then we're going to go up 2, so we outside of the radical, right? It has to be outside the radical. We're going to plus 2. All right, I don't know why it just froze